Okay, number 6, we want to use the given 0 to find the remaining zeros of the polynomial function. And what they give us is x is equal to 7i. So remember, when they tell us zeros, that is basically a linear factor of the polynomial. So we're going to use that idea to find the other term. So we have x cubed minus 8x squared plus 49x minus 392. Okay, so what they give us is that x equals 7i is one of the zeros. Because of this, we also know that x equals negative 7i is also a zero. That has to be the case dealing with imaginaries. Now, the best way, and the only way I really know to solve this, is we're going to find the linear factor. So we're going to set this equal to 0. So we're going to subtract 7i. That's going to give us x minus 7i here equals 0. And then we're going to add 7i here to the other side. So we're going to get x plus 7i equals 0. Okay, these two are linear factors. They come from this. We're missing one more because we have a degree 3. So we have 1 here, 2 here, we need one more. The way we're going to find that is we're going to do long division. We're going to first multiply these two together, and then we're going to do long division with what we have left. So we're going to take x minus 7i times x plus 7i. Hopefully you notice difference of squares, all right? And this turns into x squared minus 49i squared. Recall that I squared is equal to negative 1. So we get x squared minus 49 times negative 1. And this will simplify to x squared plus 49. Okay, now we're going to do long division. So we're going to take our original polynomial, that is x cubed minus the 8x squared plus 49x minus 392, and divide it by these two that we multiplied together, x squared plus 49. So we're going to do this, we're going to do long division. So I'm going to just do a side note here. All right, so think about long division with numbers. Let's just say I was dividing 3 into 546. It's going to be similar, but a little bit different. So we would first see how many times will 3 go into 5. 3 will go into 5 once, so we would write that up there. And then 3 times 1 will give us 3. And then once we do here, we would subtract. We always change the sign, or we do the opposite. So I'll subtract, and then this becomes a 2, and then we bring down our next term. So then I would be looking to see how many times will 3 go into 24. Well, 3 goes into 24 8 times. So 8 times 3, we would write 24, and then we subtract, so change sign, and then we would get 0, and we would bring down our last term. And then how many times will 3 go into 6? 2 times. This kind of worked out nice this time. And then 2 times 3 is 6. We subtract, and it ends up being 0. Now, normally when you just make up numbers, they don't work out nice, but it happens every once in a while. So this is the process. You try to make how many times will this go here, you subtract, and then we solve. So the bottom goes on the outside, the top goes inside. We're going to do long division. I'm going to show you exactly how this works. Okay, so I'm going to use more paper because I'm out of room here. So I'm going to set it up as a long division problem. So x squared, Now I'm missing my x term in the middle, so I want to put something as a placeholder. So I'm going to do plus 0x. So times 0 times anything is 0. So I haven't really changed the problem. I just put this as a placeholder. And then plus 49. That's important because it just kind of helps you keep everything lined up. We have a second power, first power, 0 power. All right, now we're going to write our polynomial, x cubed minus 8x squared plus 49x minus 392. Okay, so when we're doing long division, we only focus on the front term, these two. So I want to know if I have x squared, which means I have 2 x's, I want it to be the same as this, 3 x's. How many more would I need? What would I need to multiply this by so that it gets the same? Well, we would need to multiply by x. When you multiply the same base, you add the exponents. So if it was a coefficient here, I would also need the numbers out front to be the same. In this case, the numbers are 1, so we don't have to multiply it by any number. So we're going to multiply each of these terms by x and line them up, change the sign, and then simplify. So when I do x times x squared, we get x cubed. When I do x times x, we get x squared. So I'm just going to say plus 0 x squared. So if you didn't have this term here, you wouldn't know what to write here, and it would kind of mess everything up. Then x times 49 would just give us 49x. Okay, so once we do this, what do we do with the numbers? We subtract it, or we change the sign. So this becomes negative, this becomes negative, this becomes negative. So I'm getting rid of these positive signs because we have to subtract. So when I subtract x cubed and cube, it goes to 0. That should always be the case. Negative 8, take away 0, I will still have a negative 8x squared. And then with the 49 and positive and negative, they will go to 0. All right, and then you bring down your last term, which is the negative 392. And we're going to just repeat the process. I'm only focusing on the front and the front. Okay, so notice I already have the x squareds the same. I just need the number in front to be the same. So we have to multiply this term by negative 8 so that these are equal. So I'm going to write a negative 8 up here. That's the term I need. And when I do negative 8 times this guy, I get a negative 8x squared. Negative 8 times the 0x will just give me 0x, because 0 times anything, the 8 and 0 give me 0. And then we will do negative 8 times 49. Okay, negative 8 times 49, bigger number than I want to do mentally. So quit, and we will do negative 8 times 49, and that gives us a negative 392. Okay, so once we finish doing that, the process was to subtract. So all the signs change. This will become negative. It was already negative, it becomes positive. This is negative, this will become positive. So opposite signs go to 0, that is 0, and this goes to 0. So we have no remainder, which is what we want. This up here is the remaining linear factor, x minus 8, which we set equal to 0, and that will help us find our last 0. If you add 8 to both sides, we get x equals 8. So altogether, the zeros are 8, 7i, and negative 7i. And we can write it as linear factors if we need. But in this case, it just says to find the remaining 0. So the remaining 0 is 8. So if you put x minus 8, you're going to get it incorrect. It's just 8. So you got to set it equal to 0 and solve for x. Okay, so let me see the remaining zeros. Okay, I forgot. I also need to add the minus 7i because they didn't give us that one at the beginning. So we get 8 and the negative 7i. That also was not. We had to come up with that on our own.